attention. This is just the beginning. I'm going to explain it briefly, so pay attention. So now, in time graph, we have three main types of time graph. We have the distance time graph, we have the displacement time graph, and the velocity time graph. Yes, this is velocity time graph, and this one here is the most important because this is where examiners focus on during jam and right velocity time graph. So now pay attention. When you have a distance time graph, you draw a graph against distance and time. The slope gives you what? The uniform speed. Take us the key points you need to know. The slope of a distance time graph gives you what? The uniform speed. You can see it here. In a displacement time graph, the slope of a displacement time graph gives you what? Uniform velocity. It's within the uniform what? Velocity. This one is what? Uniform speed. Because of that. So now, in the velocity time graph, in VT graph, it has three cases. Now in case one, I see that the slope it's a positive slope. I mean it goes upward. It's like it's increasing. Now this is a what? A uniform acceleration. Anytime I draw a graph against V and T, and I notice that the velocity increases with time. That's that the velocity is increasing with time. It's called what? Uniform acceleration. The slope here is what? Uniform acceleration. Take note of that. But in this one, in this VT graph, so in this one now, in this VT graph, the slope, the velocity is reducing with time. You see, as time increases, the velocity what? Reduces. It is called what? Uniform what? Retardation. Uniform what? Retardation. Because you see, the velocity what? Reduces with time because the velocity reduces with what? Time. It's called what? Uniform retardation. So in this case, in case 3, you can see that I have a straight line like this. You can see that I don't have any increment in the what? In the velocity with time. The velocity what? Remains constant. It does not go up nor come down. It's just what? Like that. So in this case, I will call it what? Uniform what? Velocity. And at uniform velocity, there is no what? Acceleration. It does not increase or decrease. So it has a zero acceleration. Think of that. So now I said here that the slope of a velocity time graph gives what? Acceleration. Yes, and to calculate this slope, that would be v2 minus v1 over t2 minus t1. In the main class, I'm going to teach you this. So now the area under VT graph gives what? The distance traveled. So if you want to find the area under a VT graph, you just have to find the area of the shape that is given. So that's just it. So now the area under VT graph gives what? The distance traveled. So just take note of that. So now, hope you're in the main class. So now I'm going to be solving questions. So please make sure you like, comment, and share. Let's move to solving past questions. So now I'm going to be solving 2 questions on this swiftly. So I want you to pay attention to this. I'm going to be showing the question on your screen. Yes. So now the first question says that a car starts from west and accelerates uniformly for 5 seconds. Now the first thing I will do is to draw my graph and my VT graph. So now this is V, right? This is V. This is what? Is T. So just pay attention to what I'm going to do. They say that a car starts from west and accelerates uniformly for what? For 5 seconds. Now it starts from west, accelerating uniformly for 5 seconds until it attains a velocity of 30 meters per second. So it starts from west. This is rest from the starting point. I mean, it accelerates. Accelerates means that the velocity is increasing. I mean, uniformly with time. I mean, so now it accelerates like this. Acceleration. Now I showed you the graph. Now accelerates uniformly for what? For what? For 5 seconds. Now for 5 seconds. Now. For 5 seconds, actually this is 5 seconds here. For 5 seconds until what? Its velocity becomes what? 30 meters per second. So it means that the velocity here is what? Is 30 meters per second. Let me write it. It's 30 meters per second. This is what? It's 30. I mean, yes. So they said that it then travels with uniform velocity for 15 seconds. So now it's maintaining its velocity, like uniform velocity means that it does not increase or decrease. That means it goes like that straight. It travels with what? With uniform velocity for 15 seconds, then it goes like this. Abi, continue like it maintain its speed uniformly for what? 15 seconds. Just pay attention to what I am doing. This is T now. For 15 seconds. So now the distance between here and here is what? 15. Abi, so but I'm not going to write 15 here. I have 5 here. 5 plus 15 is what? 20. So the distance from here to here is what? 20. But the distance from here to here is going to what? 15. I hope you know it's maintained its speed for what? 15 seconds. So from here to here is 15. But in this case, I will not write 15. Why? Because from here to here, if from here to here is 5, from here to here is 15, from here to here is what? 5 plus 15, that is what? 20 seconds. Hope you understand? Yes. So now, let's continue the question. So they said for 15 seconds before decelerating uniformly to rest. So it decelerates. To decelerate means to reduce. Before decelerating uniformly to rest, what? In 10 seconds. So it decelerates, it comes down to rest for what? For 10 seconds. So from here to here is 10. If from here to here is 10, and from here to here is 20, from here to this side of the board, going to be what? 30 seconds. And you know that the time is in what? It's a second. So now, what they ask us to look for? Number one, they say we should sketch a graph of the motion. Now, that's what I've sketched the graph already. I've sketched the graph already. This is how the graph should look like. The first step in attempting a time graph question is what? Sketch the graph. Once you sketch the graph, you are good to go. So now, what they ask us to look for, they say we should calculate the acceleration during the first second. They want us to calculate the acceleration from here to here. Acceleration from what? From here to here. The acceleration. Now we can do it. Now if you can remember, I told you that A is equal to what? Change in velocity over what? Over time. Abi? Yes. So now, since the body was starting from rest, the initial velocity is what? Is 0. Abi? Yes, so starting from rest now, say from down, it goes up. It started from rest, initial velocity goes to what? 0, that will be 0 meter per second. Abi? The final velocity here is what? Is 30. So this goes to what? 30 meter per second. Abi? And the time it used to what? Accelerate is what? Is 5 seconds. So T is what? 5 seconds. So to calculate it, I'm going to have that A is equal to what? 30 minus 0 over what? 5. So that's going to be 30 over 5. So my acceleration here is going to be what? 6 seconds. 6 meter per second, sorry. 6 meter per second. As simple as what? ABC. So I've solved the second question. What they asked me to look for next? They asked me to what is the question? They asked me to what? Calculate the deceleration during the last 10 seconds. This is the last 10 seconds now. Remember the deceleration. Anytime they ask to find acceleration, you move here towards up. Anytime they ask to find deceleration, you move to the ending side where it goes down. You understand? Yes, so they have to calculate the deceleration during the what? Last 10 seconds. So if you can remember, acceleration and deceleration is the same formula we're going to use now. So now CO. So A is equal to what? V minus U over what? Over T. Abi? So now in this case, pay attention. In this case, the velocity was what? Was at 30. Pay attention. In this case, the velocity was at 30. Abi? Then it comes to rest. It became what? 0. It decelerates what? To rest. That means it came to 0. So initially it was at 30. So in this case, U is now going to be equal to what? 30 meter per second. 30 meter per second. Abi? Then it came to rest. It was brought to rest. So now V here is going to be what? 0 meter per second. You understand? Yes. And the time it took to decelerate, the time between here and here is what? Is 10. 30 minus 20 is 10. So T is what? 10 seconds. So to find the deceleration, I'm going to have that A is equal to, since V is 0, that will be 0 minus U is what? 30 over what? Over 10. Abi? Yes, so I'm going to have that A is going to be equals to minus 30 over 10. If I divide, A is going to be equals to minus 3 meter per second square. So the acceleration is on minus 3 meter per second. So, but they have to find what? Deceleration. So So now, if it's deceleration, I'm going to have the minus sign. So minus a is equal to 3 meter per second squared. So as acceleration is what? A. Deceleration is what? Minus a. Take note of that. So you can see that it's very, very simple. So in the next one, you have to calculate the total distance traveled throughout the what? Entire motion. That's how to calculate the total distance traveled throughout the entire motion. Now, anytime they ask you to calculate distance traveled in a velocity time graph, is for you to find the area of the shape that is given. Now, in this what I'm saying here, anytime they ask us to find the distance traveled in a VT graph, I'll look at it. What shape is given here? Is a what? A trapezium. I'll now look for the area of the trapezium. That's all. Distance traveled is equal to what? Area of the shape that is given. So now, and the shape here is what? A trapezium. So to calculate distance, about calculate the area of this trapezium here. So now, distance S, I just use S as the distance, is equal to what? Area of what? Of trapezium. Yes, so an area of a trapezium is what? What's formula for area of a trapezium? That's what? Half bracket what? A plus B H, abi? Half bracket A plus B plus bracket what? H, abi? Where A is the upper length, B is the what? Is the lower length, abi? And H is the what? Is the height of the trapezium. So now, that is because 1/2 brackets. What's A here? I thought that A is the what? The length from here to here. Now, if here is 5 and here is 20, listen, if here is 5 and here is 20, the distance from here to here is going to be what? 20 minus 5, that's going to be what? 15. So now it means that here is going to be, A is going to be what? 15 plus B is the lower length. Abi, yes, B is the lower length. So and the length from here to here is what? Is 30. In a very simple. That's what? Plus 30. H is the what? H is the height. The height from here to here is what? Is 30. So that would be what? Times 30. It's very simple actually. So now X is going to be equals to 1/2. 15 plus 30 is what? 45. Times what? Times 30. 2 here 1. 2 in 30 is what? 15. So S is going to be equals to 45 times 15. What is 45 times 15? That's what? 675. That is what? 675 meter. As simple as what? ABC. So don't forget to like, comment, and share. Let's move to the next question, please. So now let's move to the second question. Yeah, I'm going to show it on the screen, I promise. So now, in this question, it says that a car starts from west and accelerates uniformly for 20 seconds. The first thing I'm going to do in this case is to draw my graph. As usual, let me do my graph first. This is T now, this is the time, this is velocity here. Right? Yes. V in meter per second. So now they say that a car starts from rest and accelerates uniformly for 20 seconds. Now it starts from rest, that's from here now, then it accelerates, it goes up, accelerates uniformly for what? For 20 seconds. So the time here is what? Is 20. The time down here is 20 seconds, abi? Yes. Until to attain a speed of what? 25 meters per second. So now the speed it's attained here is what? 25. 25. Hope you know that the velocity is in meters per second, right? And the speed is in seconds. The time is in seconds, abi? Yes. So now until it attain to attain a speed of what? 25 meters per second, right? It maintains this speed for 30 seconds. It maintains the speed, means that it continues with the speed. It did not accelerate to decelerate. That means the velocity is constant. Speed is constant for what? For 30 seconds. It's maintained the 25 for 20 for what? How many seconds? For 30 seconds, right? But let me look at the question. It's maintained the speed for 30 seconds. Where is it? Is it 30 seconds? Yes, for 30 seconds. Now it's maintained the speed for what? 30 seconds, abi? Yes, now if it's maintained for 30 seconds, it means that the distance between here and here is what? Is 30. So now if from here to here is 30 and from here to here is 20, from this side to here what? 20 plus 3, that is what? 50 seconds. Abi? Okay, then it says what? Where's the question? Before decelerating uniformly to rest, then it was brought to rest. It decelerates, that means it comes down to rest. Abi? Before decelerating uniformly to rest, the total time of the distance was 60 seconds. So the total time is what? 60 seconds, right? Yes. So now after you've already done this, you don't have any problem again. Like the problem has been solved, that has been settled. Now what did I have to look for? They say we should number one, sketch the velocity time graph. I've done that already. Now the next one, they say we should calculate the total distance traveled. This is actually the simplest. I tell you that to calculate the total distance traveled in a VT graph, you just calculate the area of the shape that it's formed. Abi? Yes. Now, so the area of this shape is a trapezium now. So the distance is going to be what? Area of the trapezium, which is what? Half bracket A plus B close bracket H. This is A and this is what? B. Abi? Yes, that's going to be equal to 1 over 2 bracket A. The distance from here to here is what? 50 minus 20. That's what? 30. Yes, if you remember, I did that it's maintained the speed for 30 seconds. For me, it's 30 normally. Now that's going to be 30 plus the distance between here and here is what? 60. You can see that it's 60 plus what? 60 times the height that's from here to here, and the height from here to here is what? Is 25 times what? 25. Yes. Now that is equals to 1 over 2 times 30 plus 6, that's what? 90 times what? 25. I mean 2 here 1, 2 in 90 is what? 45. So what's 45 times 25? Let me use my calculator. 45 times what? Times 25. That's what? 1125. Sorry. 1125 meter. As simple as what? A, B, C. So now let's solve the next one briefly. What's the next question? They say we should calculate the deceleration of the car. I tell you that anytime you ask to find the deceleration, you look towards the ending. Anytime you ask to find acceleration, you look towards the beginning, because it accelerates here, it decelerates here. You understand? So now they have to calculate the deceleration of the car, So now the next one, B, we have to find the deceleration. A is equals to what? V minus U over what? Over T. Abi? Yes. So now A is going to be equals to V here. Wait, I should simplify the data here. V in this side is what? Is 0. Abi? Yes, because it was initially at 25 and it came to rest to become 0. You understand? Yes. U is what? The initial speed at the side, that's what? 25 meters per second. While T is the distance between the deceleration, and this is where the deceleration started. So from here to here, that's going to be 60 minus 50, that's going to be 10 seconds. So now I include the formula. So here is going to be equals to V is what? 0 minus U is what? 25 over what? Over 10. So I have A is going to be equals to minus 25 over what? 10. So here is going to be equals to what? Minus 2.5 meter per second squared. But I'm not looking for acceleration, I'm looking for deceleration. So the minus will come here. So minus A is going to be equals to what? 2.5 meter per second squared. So this is my answer. So minus A means deceleration of retardation. A means acceleration. And if they ask to find acceleration of the car, the answer will be what? Or the result will be on minus 2.5. Take note, but if it's deceleration, it's going to be what? 2.5. Use your head. Now, this is going to be the last question for this course. So just pay attention. Now, please make sure you like, you comment, and you share. If you have any question, please feel free to ask. Subscribe to my YouTube channel. Share it to your friends. Let them watch and know. Okay. So now the last question, they said here that I'm going to post it on the screen, I promise. Now they said that a car starts from rest. So I'm going to draw my graph first. You understand? Yes. First draw your graph. That's very, very important. Yes. So this is going to be T in seconds. This is going to be V in what? Meter per second. Yes. So now they said here that a car starts from rest. and accelerated uniformly at the rate of 3 meter per second square. Now it accelerates uniformly. It goes up from rest from here. It goes up at the rate of 3 meter per second square. So now if you go and write the velocity as 3 meter per second square, you feel it. They gave us the acceleration here instead of the velocity. So you don't have to write it. You will use it to find the velocity. Just listen. So now listen up. A car starts from rest and accelerates uniformly at the rate of 3 meter per second for what? For 5 seconds. So the time given here is what? 5 seconds. 5. But I don't have the velocity. It was the acceleration that is given to me. You can see the unit here. That's meter per second. So that's acceleration. The acceleration, I'm not going to use the acceleration and time to find the velocity. Listen, A is given as what? Pay attention. A is given as what? As 3 meter per second square. C is given as what? As 5 seconds. Pay attention. Anytime something like this is given to you, you use it to find the velocity. Then since it's starting from rest, it's going to be equal to what? To 0. And I'm looking for what? V. Now, which formula am I going to use to link what is given to me and what they are going to find? I'm going to use the first equation of motion. That's going to be V is equal to what? U plus what? AT. As simple as what? ABC. So now, that's going to be V is going to be equal to U is what? 0 plus A is what? 3 times T is what? 5. So V is going to be equal to what? 15 meter per second. Simple. So now my V here is what? Is 15. My V here is what? 15. So don't make the mistake to use acceleration for what? For velocity. Sometimes they want to confuse you, but show them that you are so deep, you have sense. Understand? So now let's continue the question. It said that it attains a velocity which is maintained for 1 minute. See, they want to use your editing. Instead of them to say 60 seconds, they said 1 minute. As some of you have to do 5 plus 1, you have to say, what's failure? They have failed it. So now, it attained the velocity, that means it will remain constant for what? For 60 seconds. For 1 minute. 1 minute is equal to what? 60 seconds. So now, I'm not going to write 60. Remember, I'll go write 60. From here to here is 60. From here to here is 5. So the total distance will be what? 65 sharp. Put this and put it together and good to go. So now, then the answer that it was brought to rest after what? After 3 seconds. It was brought to rest after what? 3 seconds. So it was brought to rest, that means it decelerates after 3 seconds. So from here to here is 3. So from here to here is going to what? From here to here is 3. So from here to here is going to what? 68. You grab. 68. You grab. It was brought to rest after 66. So then now also to calculate the total distance covered. Simple sheet. So now also to calculate the total distance covered. Let's do that quickly. To calculate the total distance, that's the area of the graph. The area of the shape in the graph. And the shape here is what? The trapezium. So now I'm going to have that S is going to be equals to half bracket A plus B H. Yes. So now that's going to be equals to 1 over 2 bracket A is the distance from here to here. And the distance from here to here is what? 65 minus 5. That's going to be what? 60. 60 plus the distance from here to here is what? 68. 68 times H. H is the height now. That's just 15. Simple thing. Now that's going to be equals to 1 over 2. Now what's 60 plus 68? That's going to be 128. Yes, 128 times what? Times 15. So 2 here 1, 2 in 1, 2 is going to be what? 64. So now what's now 64 times 15? 64 times 15 is what? 960 meter. 960 meter. So you can see that it's very, very simple. So the distance covered is what? 960 meter. So if you have any question, feel free to ask. And what video course do you want me to do next? Make sure you like, comment, and share. Now don't forget that Success Tutorial Jam class is currently ongoing. To register is just 4,000 naira. The fee is just 4,000 naira monthly. So send a DM to register. Message the number on your screen to register. God bless you. My name is Dismantled.